Okay then guys, this is for AS students and any A2 students who want to have a look at stuff. I've sort of introduced AS students to haloalkanes and told you that it's a nucleophilic substitution reaction, how to make a haloalkane, right? You can use, you can take an alcohol and you can react it with chloride, bromide or iodide and make the haloalkane. Okay, you can go the other way. You can take that, which we will do, you can take the haloalkane and use sodium hydroxide to convert it into an alcohol. Both of those are nucleophilic substitution. They're very similar and they go both ways. Now, I'm going to do a PAG with you, right, to prepare a haloalkane. So I'm going to show you some practical techniques as well. This is an virtual experiment, if you want to call it that. All right, guys? Yeah, I want this copied down, I want this written out. I don't want you to just watch the video. I expect to see this all copied out nicely, okay, and enhanced with anything else you can find from other videos, because there's experimental techniques in this that we need to look at. Right, okay, what are we going to be doing? Right, we're going to take, excuse me, right, we're going to take this substance here. So I want you to put down title, PAG. You will write this. You can't do it in your practical books, but that doesn't matter. Do it on paper. PAG 5.1, synthesis of a haloalkane. A lot in this. Basically, this is the reaction we're going to be doing. Right? We take an alcohol. There. Two methyl propan 2 of tertiary alcohol. Now I've told you that you can, well, I don't know, you can use a number of things to get your haloalkane. You need something with a halogen. You can use sodium. I'm going to produce a chlorohaloalkane, so I can use sodium chloride and acid or directly hydrochloric acid. I need the chloride in the mix in order for it to act as a nucleophile. In this particular reaction, I'm using concentrated hydrochloric acid there, and we are going to end up with this. Simple, we swap, we substitute the OH for the Cl, everything else stays the same. So we're going to make 2-methyl whatever it's called, 2-chloro, sorry, I've got it the wrong way around, 2-methyl, 2-chloro propane, 2-methyl, 2-chloropropane. That's what we're going to do. Right, I'm going to try and explain to you how we do this, okay? It won't be perfect, but it'll be okay. Right, so we take this 2-methyl propan 2-ol, okay? And we put it in a conical flask. Never mind how much, I think it's about, so this stuff into a conical flask. 2-methyl propan 2-ol into a conical flask. We add hydrochloric acid. Drop by drop, make notes about that so you don't get too much heat generated. In it goes into there, drop by drop using a pipette. And the reaction is quite rapid with concentrated hydrochloric acid. The reaction will take place at room temperature and you will make your product, this stuff here, your haloalkane. Drop by drop, shake it repeatedly and you'll make the product. So in here, now that comes onto the second and most, so it's very straightforward. You take your alcohol, concentrated hydrochloric acid, and it goes drop by drop, bit of shaking, bit of stirring, you're going to make 2-methyl-2-chloropropane, your halo alkane. But probably the most, so that's easy, Now I'll show you the mechanism for this as an aside, I suppose. Right, so, because you're not that familiar with these, it's dead straightforward. What you have here is your alcohol right there. And you're going to have a delta plus, delta minus polarity there between the C and the O. This is sort of the backwards one from one I just showed you earlier. You've got chloride nucleophile here, right there. Right, it's that easy. Bang into there. Bang and breaks. Okay, making this product. To make sure those arrows are a bit tidier than mine, please. Right, so C, Cl, CH3, CH3, job done. That's the reaction we're going to do. Now, you do this reaction, what do you end up with in the conical flask? And this brings me on to probably a more important part of this, separating out the mixture of organic products. And you've sort of done this, we've looked at separation techniques with distillation, but this is a new separation technique using a separating funnel, okay? Now, I don't want to wipe this off just yet, so we'll keep it on. What's in here? Because you don't get like 100% reactions, do you? It doesn't work like that, all right? You always get a mixture of different products, okay? So, in here, you're going to have unreacted alcohol. Because not all this will go. Unreacted 2-methyl-propan-2-ol. Let's just call it, I don't know, alcohol. Right? Because not all of it will react. You're going to have quite a lot of concentrated HCl. Because it's not all going to get used up. You're going to have your product, your halo alkane. Right, which is 2-methyl-2-chloropropane there. Product and possibly isomers, you know, structural isomers. So you could get, so that's your product, your isomers there. Okay, now that is what we need. So I put an asterisk by that. And you're going to have H2O is kicked out. I'm sorry, I nearly forgot that. You're going to have water. All of that in here. Water. Right? Now, how do you separate that lot? You wouldn't do distillation of that lot straight away. It's not the right thing to do. There's a better way of separating things. Distillation is a more fine-tuned way of separating things, when you've got like a couple of organic compounds with different boiling points. This, you've got a right mixture of stuff. So you have to use a technique that's a bit more, I don't know what the word is, that works better than distillation, that separate. Basically, you're going to use a separating funnel to separate water-soluble, aqueous substances and organic insoluble, water-insoluble substances, and that's your first. If you ever get a mixture of those type of things, you have to use a separating funnel. First time we've ever seen this, guys. So let's take this and let's see. Now I'm going to keep this on the board, right? Because I'm not so sure about rubbing it all off straight away. So this is, we've finished with this. Okay, we've finished. You know what's made here, right? I want to take this forward. So you take all of this stuff, right, goes into a classic piece of kit which you would be using called a separating funnel, which I will draw for you now, right? We've got them here, but I can't quite access them at the moment, and they look like that. They clamp they can clamp, and they've got a tap at the bottom like that. And they are for separating mixtures, but without the faff of distillation and all the different possible, distillation can cause problems because you're heating things up. So in it all goes into a separating funnel. Now, what's going to happen? It's going to separate. Okay, so a separating funnel allows for natural separation according to what things are soluble in what. So in here, right, two layers, two distinct layers. Okay, layer 1, layer 2. Top layer is your organic layer, what you've made, your haloalkane, and any other impurities that are organic in nature, such as isomers of your haloalkane. Right? So your haloalkane product, that is an organic product, an organic stuff. Hydrocarbons float, that's your top layer on aqueous, on water and anything that's in it. So all that is there, haloalkane product. Underneath is a number of things, all of which are soluble. So that's your organic layer with your product. This is your aqueous layer, stuff that's attracted or soluble in water. That's why the separating funnel is quite good, because it does that straight away. Okay, in here, you're going to have, in here is going to be your unreacted reactant, your alcohol. Okay? In here is going to be hydrochloric acid concentrated. For we've used that, so there's going to be loads of unreacted. 1, 2, okay? In here there's going to be water as well. 3 components in there. No problem. You put a stopper in, but you must release the pressure, and you shake, okay? So that it all gets nicely separated, okay? Shake, and then run off the aqueous layer. So you undo the tap, and out the aqueous layer goes. And you know what? You're going to be left with, well, we'll go up here because I think it's easier for me to see if nobody else. You end up, if you run off the lower layer, with this. Alright, with this. Just your organic layer. So this is you put them in the funnel, you run off the organic layer, you reach stage 2. Organic layer left in there, you keep that and you run it off to about there, because otherwise, so the sort of that line there separating the 2 layers, be about there, because otherwise if you go too far you lose some of your product. And this stuff, drop through, you discard because it contains unreacted alcohol, concentrated HCl, water, anything that's water soluble. Bang, there's 2. Okay? Now, that's not as good as it can get. You can sort of what you might call wash it or dry it as many times as you like. So you've got your organic layer, but you've still got a bit of aqueous there at the top. So, stage number 3. Running out of space. We'll go, I don't know really. 1, 2, 3, get rid. We'll go down here. 3. You can use this to wash again and again. So number 3, right, you got your separating funnel there. Add some water. Shake. Let it settle. Back to this. Creating another aqueous layer, but you've got rid of a load of stuff. Organic layer, aqueous layer. Tap. Run it off. So now you've got an aqueous layer again. So you're creating another aqueous layer. You can get rid. And then you run it off. And you're back to this layer again. So, but a bit cleaner. Organic layer. Bit cleaner. Alright? Okay, now, there's another thing that you can do. to make it absolutely right, because this organic layer will still have unreacted hydrochloric acid in it, okay? So the other thing you can do, and just let me get my notes, excuse me, because I don't want to, if millions of people are watching this, I've got to be right, haven't I? What the hell? Yeah. There's a lot of other stuff in here, but basically I'll keep to the basics. Otherwise we'll be here all day. Okay. Right then. So you can add a solution, and you can do this at the same time as you add water. Add a solution of sodium hydrogen carbonate or some kind of carbonate. What will that do? Well, you know if there's any hydrochloric acid that's left, right? Because there will be, it'll fizz. There always is. It'll fizz, okay? And your hydrochloric acid will react with your sodium hydrogen carbonate, right? To get rid, it will neutralise it. Hydrogen carbonate is just the same as carbonate, basically. And you'll get sodium chloride, and you'll get fizzing of CO2 and water. It's not a perfectly balanced equation, but a hydrogen carbonate or a carbonate will react with an acid to make those things. That will fizz off. So when you add your sodium hydrogen carbonate, this organic layer, you get fizzing, CO2. Any acid will be used up, right? And you get water. So you're going to generate a lower aqueous layer. And you can put some more water in and shake it again. But what that will do is, and you can repeat that process, so your solution of sodium hydrogen carbonate's purpose is to neutralise the hydrochloric acid, because you don't want it, right, like that, to turn it into salt, get rid of the CO and water, creates another aqueous layer, which you can run off. So you can repeat this process as much times as you want, and you're sort of cleaning the organic layer. That's what a separating funnel will do for you. So in summary, it separates any aqueous components from any organic components, any aqueous, in this case reactants, from organic products, the haloalkane, right? Separates that, and you can sort of wash it by adding more water, and you can neutralise excess acid by adding sodium hydrogen carbonate solution, again into your separating funnel, a bit more water, you get fizzy, but it cleans the organic layer. That is how a separating funnel works. Wherever you've got a mixture of water-soluble and oil-based components in your reaction mixture. Now, there is a fifth purification. So you've done this a few times. Finally, you run off your organic layer. What you want, your haloalkane that you're trying to make, whatever it's called, right? This baby here. Right? That's what you want. But all organic reactions, all organic reactions have so this is just the organic layer, but they all have impurities, you know what I mean? Right, but now you've got rid of your aqueous stuff, you've got rid of a lot of crap. Now you can use a more refined technique to purify your organic product exclusively, okay? And the organic product that you're going to have exclusively is this. How do you do that? Distillation, right? In other words, this here, I need to check this, so bear with me a minute. According to this, the product you want boils at about 48 degrees C. So you set up a distillation apparatus which badly drawn, right? I don't any of this in the exam. Heat, water jacket, you know the score. Just the organic haloalkane in there. You've done all your separating with your separator for all the aqueous stuff's gone. Take it up to 48. Keep the temperature at 48, thermometer stuck in there. That's the still head. Right, keep it up to 48. Capture the fraction between about 48 and 50. And that fraction there is the fraction at which the product you exclusively want, the haloalkane that you want, will distill off, leaving any stuff you don't particularly want in the reaction mixture. That technique produces for you a pure haloalkane. I want that written up, and I want it written up properly, and I want you to look at other things on YouTube and anything else you can find to have a look at that reaction and acquaint yourself with how separating funnels and that works. But that is a PAG 5.1. So write all that up for me, please, guys, properly. Thank you very much. See you later.